Hello, good morning. Can you hear me? Good morning, everyone. Paki-confirm po if you can hear me. I-type po ng anything doon sa comment section natin. We have Early Bird, Kenneth Dave Kahoy. Good morning. Dinig po ba ako? Loud and clear. Okay, very good. Okay, good morning, everyone. Okay, so let's start our session this morning with a word of prayer. Heavenly Father, we thank you for this beautiful morning, and we thank you, God, for your grace, for adding another day in our lives. And I just want to submit to you our session this morning. May it be productive. May my students learn a lot of things today, and may you be glorified even as we do our review session today. We just want to give you all the glory and praise in Jesus' name. Amen. All right, so good morning, everyone. So panibagong session for hydraulics. I hope that you had a good weekend and you had a good rest. So this morning, we're going to continue our discussion on the different flow measuring devices. Last time, we were able to talk about the orifice. Today, we're going to have a discussion on pitot tube, also venturi meter, and then finally, about weirs. So in the first half of our lecture today, we're going to talk about pitot tube and the venturi meter. And then after our break, we're going to discuss about the weirs. So let's start our discussion about pitot tube. Okay, so a pitot tube is a device used for measuring velocity of flow at any point in a pipe or a channel. Okay, so this is just a piece of metal that we insert on a pipe, no, and its form is like this one. So let's say we have here a tube, and then flow Q is there, no, and it is flowing in this case from left to right. And then if we're going to insert a piezometer, so we know that piezometer is a device that is inserted on the tube, which is able to show us the pressure head. So of course, water will rise at a certain point. No, we call that height as our static head. And then let's say that the point at the surface, we call it point A. And then point 1 is a point below the piezometer. So the head, H1 there, we call that the static head. So that represents no, the pressure head of our water as it flows in this tube. And then yung pitot tube naman, yan yung in-insert natin na right angle yung kanyang uh, bend no, sa may baba. So yung pointed end niya, it is inserted no, against the direction of the flow. And of course, water as well will rise. And if you notice, yung kanyang head is slightly higher compared sa piezometer. So that is because no dito sa piezometer or dito sa pitot tube, nagkakaroon tayo ng stagnation point. So yung stagnation point, yan yung point 2 natin. Okay? So dyan sa point 2, yung velocity natin dyan is going to be 0. Okay? And since the velocity there is going to be 0, so magko-compensate no, si pressure head. Kaya yung pag-rise ng head ng tubig dyan, column ng water, dyan sa pitot tube, that is a combination of your static head and also our dynamic head. Okay? So, ayun. So, yung pressure difference dyan, yan yung gagamitin natin as reference for computing the velocity later using Bernoulli energy equation. Okay? So, of course, meron din yung sariling head H2. And so, again, the basis or the principle behind pitot tube is that the velocity of flow at point 2 is 0. Okay? So, considering that there is no head that is lost, so you could say that energy at point 1 equals energy at point 2. Expanding the energy equation, and then we want to know or we want to measure the flow or the velocity of flow at point 1. So, in order to do that, no, we'll use the Bernoulli. So, supply natin mga ano. So, of course, sa point 1, that is V1 squared over 2G. So, ayan yung gusto nating malaman, yung V1 na value. Yung G, of course, we know that as 9.81. And then, yung pressure head, assuming na yung piezometer at point A is open to the atmosphere. So, pressure head there would be 0. And then, yung elevation head natin, so, assuming na yung datum line natin would be yung nasa gitna ng tube natin. So, yung elevation head sa point 1 is H1 equals velocity head sa point 2. So again, sa pitot tube, tandaan natin, ang velocity po sa point 2 ay 0. Okay, so 0 yung velocity head dyan. And then, pressure head, of course, open pa rin sa atmosphere, so that would be 0. And then, we have the elevation head, that is H2. Okay? So, solving for V1, isolate mo lang yung V1. Ang H1 transpose natin sa right side. So, that is going to become H2 minus H1. Then, cross-multiply lang natin. And then, square root both sides. So, that would be V1 equals square root of 2G H1. This is supposed to be H2 minus H1. Okay? Correct ko lang. So, this is H2 minus H1. Ayan. Or, you could say that the difference ng height, no? That would be H. Ito. And then, palitan natin yung H2 minus H1 ng H. So, ibig sabihin, yung velocity sa point 1 is going to become square root of 2gh. And again, yung value ng velocity dito, this is considered as a theoretical velocity. Kasi hindi tayo na-consider ng head loss. Okay? So, bale, ito yung formula ng pag-compute ng flow dito sa point 1. No? So, that is simply V1 equals square root of 2gh. And again, emphasize ko lang, h there is the difference of the heads at point 2 and point 1. Okay po? Sige, so let's solve some example problems. Okay, so air with a unit weight of 12 Newton per cubic meter is flowing through a system shown. So, sa figure natin, meron tayo dyang Venturi meter na merong tube no na nakalagay, in this case closed yung ano natin, yung piezometer, kinonnect siya sa pitot tube, tapos parang naging ano siya, U-tube manometer, no? Pero yung dulo sa point 1 is pitot tube yan. Okay? So, again, air is flowing through that system, and then oil with a specific gravity of 0.827 shows a deflection of 80 millimeters, as shown in the figure. So, calculate the flow rate, neglecting the head loss. Diameter of pipe at points 1 and 2 are 300 millimeters and 150 millimeters respectively. Ayan. So, yung tinatanong po is yung flow rate, no? Ang tanong ko po is, yung flow rate ba dito is actual discharge or theoretical discharge? Ano sa tingin nyo yung pinapahanap sa atin sa problem na to? You may type your answers in the comment section or pwede din sa Padlet. So what do you think? Are we trying to solve actual discharge or theoretical discharge? Okay. So the discharge value that we're trying to solve here is theoretical. So ano ba yung hint natin? Bakit theoretical? So again, merong ditong sinabi na we are to neglect head loss. Okay? So ibig sabihin, theoretical discharge ang pinapahanap. Okay? Kasi, 'di ba, kapag theoretical, ideal system yung kino-consider natin. And in an ideal system, wala po tayong kino-consider na head loss, no? So nini-neglect natin yung head loss due to friction and due to contraction or yung pagbabago ng cross-section, as is the case in this particular example. So nini-neglect natin lahat ng yan. So ibig sabihin, theoretical discharge po yung pinapahanap sa atin. Alright. So to solve for the flow rate, no, so our solution will have to start with the Bernoulli energy equation. Okay? So we will consider point 1 and point 2 as shown in this figure. Point 1 is the point where the pitot tube is placed, or yung pointed end niya. And then point 2 naman is yung nasa throat ng Venturi meter natin. Again, ang principle po, we will use Bernoulli energy equation We will solve for velocity at point 1, velocity at point 2, and we should always take note na sa P2 tube sa pointed end niya, ang value po ng velocity ay 0. So start tayo with the energy equation. Energy at point 1 equals energy at point 2. And then expand lang natin yung energy equation natin. Okay, V1 squared over 2G plus P1 over gamma plus Z1 equals V2 squared over 2G plus P2 over gamma plus Z2. So at this point, dapat alam na natin ha yung expansion. Okay, so again, for a P2 tube, we will assume that the velocity at point 1 is 0. Ayan. Plus, yung point 1, since closed na yung ating P2 tube, no? Kinonect natin siya sa piezometer sa point 2. So, ibig sabihin, hindi na yan 0. Okay, so P1 over gamma na yan. So, we cannot use no, yung formula na na-derive natin, yung square root of 2GH in this particular example because our tubes are closed. Okay? And then how about our Z? So, point 1 and point 2 lies in the same level. So, ibig sabihin 0 yung ating Z1. Diba? Because yung elevation head natin is always relative no to the lowest elevation. Now, since pareho silang the same elevation, so pareho silang datum line. So, 0 yan. Equals, no, velocity sa point 2, yan yung hinahanap natin. And then pressure sa point 2, that is unknown. Di pa natin alam yan. Plus yung 0 na elevation 2. So, gagawin natin, we will solve for V2. No? So, isolate natin yung term na may laman ng V2, yung ano natin. Lipat natin si P2 over gamma sa kabila. So, magiging minus P2 over gamma. Okay? So, ibig sabihin, we need to know the value of the pressure difference between point 1 and point 2. Okay, so how do we do that? Now, in fluid mechanics, no, naturo na paano mag-compute ng pressure difference in a U-tube manometer. So, i-apply lang natin yung concept na yan dito po sa problem na to. No, so we're going to sum up pressures no, from point 1 to point 2 in meters of air kasi air yung nagpo-flow dito sa system natin. Okay, so ano ba yung concept ng static pressure, 'di ba? Gamma H lang. Okay, so start tayo sa point 1, tapos pagbababa tayo magko-compute ng pressure. Of course, the sign will be plus, 'di ba? Kasi lalaki yung pressure as we go down. Sige, so P1, di natin alam yan. Tapos, bababa tayo dito sa point na to, dito. Ayan. So, ano ba yung mga heights na nandyan? So, binigyan tayo ng Y. So, from point 1 until dito, that is Y. And then, hanggang sa point na to, that is 80 mm, di ba? Okay, so start tayo sa Y. So, that would be height Y times yung unit weight ng air natin, that is 12. Okay po? And then, plus ulit, that is 80 mm convert to meters, 0.08. Okay, and then, multiply ulit sa unit weight ng air, that is 12 Newton per cubic meter. And then, principle, di ba, ng pressure. So, kapag yung points natin lies in the same plane, ibig sabihin, same sila ng pressure. Okay, so, itong point na to, same din ng pressure sa point na to. So, akyat na tayo ngayon. Punta na tayo doon. So, pag aakyat po, minus, no, yung pressure natin. Okay, so yung unang makikita natin dyan, oil na yan. So, minus pressure ng pressure head ng oil. In that case, yung height niya is 0.08. So, minus 0.08 times yung unit weight ng oil. So, binigyan tayo ng specific gravity ng oil that is 0.0827. Multiply natin sa unit weight ng water kasi yung oil liquid yan. So, yung unit weight na compute natin dapat in terms sa unit weight ng water, no? Tsaka in terms of newtons. Kaya 9810. Hindi yung unit weight ng air yung ilalagay mo dyan. Okay, then akyat ka ulit papuntang y, papunta doon. So that would be minus ulit, minus y, and then since air yan, so times 12. And then equals pressure at 0.2. Okay? So I hope wala tayong difficulty sa pag-understand paano na-compute yung pressure dyan. Okay, so yung gusto nating malaman, difference of pressure ng P1 at saka P2, di ba? So, ibig sabihin, itong pressure natin, transpose natin yung P2 sa left side, tapos yung mga values sa right side. No? Tapos take note natin, pwedeng makancel yung 12y na ito at saka itong negative y times 12 na to. So, magka-cancel po yan. So, essentially, we have a numerical answer. Sige, so paki-solve po, ano po yung pressure difference. So, yung sagot dyan, i-transpose natin mamaya sa right side. Sige, so get your calculators. Kindly solve the equation and then kindly write your answers on our Padlet or pwede din sa Facebook comment section. So what is P1 minus P2? Okay po. Kisolve po. Okay, so according to Rumia, 648.07. How about the others? I'll wait for 4 other responses. Okay, so meron nang sumagot sa Padlet, 648.07. Okay, so majorities, yun yung sagot, no? So, reveal natin. Okay, tama. So, that is 648.07. So, after that, once na nalaman natin yung value ng P1 minus P2, anong gagawin? Substitute natin doon sa hindi pa natin natatapos na Bernoulli energy equation. Okay, so substitute natin. So, V2 squared over 2 times yung G natin, that is 9.81, equals, so yung P1 minus P2 na value, that is 648.07. So, substitute lang natin dyan. And then yung gamma, ang lalagay mo dyan is yung unit weight ng air. So, what would be the value of the velocity at point 2? So, square root lang natin, no? Tapos multiply mo to doon. And then take the square root of both sides. So, what would be the value of V2? Okay, may mga sumagot ng 32.55. How about the others? Okay, Spadlet, 32.55 then. Okay, so V2 is indeed 32.55 meters per second. So again, the question is discharge. No? So velocity ang nandyan. So in order to solve for discharge, so recollect natin, no, yung formula ng flow rate, Q is equal to area times velocity. Okay, so yung diameter sa 0.2, that is 150 mm. So area ng circle, pi over 4 times diameter square. Diameter natin, 0.15, convert natin to meters. Velocity sa 0.2 naman is yung na-compute natin earlier, which is 32.55. So what is going to be the value of our Q? Okay, Facebook may nagsagot ng 0.57. Okay. How about the others? Okay. So, sagot natin for Q is 0.575 cubic meter per second. So, ito na ngayon yung flow rate neglecting head loss. Okay po? Sige. So, any question before we proceed to our next problem? Wala naman. Okay. So, let's have our second example. So, using the same principle, try to solve this problem in your paper. I'll give you 10 minutes to answer this on your own. And then we'll check afterwards. Sige, practice po tayo. So, try to solve this one. Ang kaibahan ng nito, vertical na ngayon yung pipe natin, no? Kanina naka-horizontal. Sige, so try to solve this one. Sige, so let's solve this problem. So, marami-rami na yung nakasagot. Okay, so for this problem, a mercury kerosene manometer is connected to a pitot tube as shown. The deflection on the manometer is 0.7 meter as shown, no, mercury. Assuming specific gravity of kerosene is 0.81, so we're asked what is the difference in pressures between 0.1 and 0.2. Okay, so kapag tinanong tayo ng difference in pressure, so of course, no, yung solution natin dyan is yung katulad ng ginawa natin kanina. So, start tayo from 0.1 to 0.2. Okay, so yung pressure dito sa 0.1, so same level lang sila dito, no? So, same pressure sila, so pwede tayo mag-start din dito. So, yung unknown pa yan, P1. Tapos, pag pababa, plus yung pressure natin, so that's gamma, that's 0.81. Yun yung specific gravity ng kerosene, times yung unit weight ng water, times yung height. In that case, that's 0.3. Or pwede din, since parehong water naman to, so dagdag mo lang din si X. No? Pwede isa-isahin mo, pwede ding sabay mo na. So that's 0.3 plus X. And then, pababa ulit tayo dito sa column ng mercury. So that would be 13.6, no? Times gamma water, times yung height natin na 0.7. Ayan. And then, ang pressure sa baba ng mercury, same lang din sa pressure dito sa kabilang tube. Tapos, akyat tayo papuntang 0.2. So, yung total height natin is ganyan. Papuntang 0.2. So, that is minus, kasi paakyat tayo, times 0.81 times yung gamma ng water, times yung height natin, total height natin dyan is 0.7 plus X. Or pwede ding i-separate mo, no? Whichever is more comfortable with you. Okay? Tapos, that is going to be equal sa pressure sa 0.2. Sige, tas transpose lang natin, no, yung P1 sa kabila. So, as is yung ibang values. So, ginawa natin dyan is nag-distribute, no, ng 0.81 times 0.3. So, ito yun. Tapos, 0.81 times X. Ito naman yun. 0.81 gamma water times X. Minus 13.6 times 0.7. Minus, so ito, distribute. Negative 0.81 gamma water times 0.7. And then, negative 0.81 gamma water times X. Ito naman yun. Negative 0.81 gamma water X equals P2. Tapos, si P1 natin, transpose sa kabila. Okay, so of course, magka-cancel dyan si positive 0.81 at saka si negative 0.81 gamma water X. So, we can solve now for the pressure difference. Answer is 90.213 kilopascals. Okay, so that's the answer for part A. Okay po. Sige, may take a screenshot if you want. Okay, so let's proceed sa letter B. Ang tanong dyan, what is the kerosene velocity in the pipe? So, kerosene velocity in the pipe, it is measured at 0.1, hindi po sa 0.2. So, nasa 0.1 po yan. Ang velocity naman sa 0.2, that is 0. Okay? So, gagawin natin is we will use the Bernoulli energy equation. No, assuming na neglect natin yung head loss. So, energy at 0.1 equals energy at 0.2. Expand lang natin yung energy equation. And V1 yung hinahanap natin. no? So, as easy yan kasi wala pa yung value. Pressure sa point 1, wala din yung value. Hindi naman siya open to the atmosphere. Gawin natin, lipat na lang natin yan sa kabilang side. Okay, so sulit muna natin si V2 squared over 2G. And then yung P2 over gamma. And then yung P1 over gamma, no? Na ngayon magiging minus na. Kasi transpose natin sa right side. Plus Z2. And then minus yung ating Z1. Okay? Pagkatapos is ano natin. Gusto nating malaman dyan yung velocity sa point 1. So, knowing na yung velocity head sa point 2 is 0 kasi nga yun yung concept ng pitot tube. 0 yung velocity sa point 2. So, 0 yan. And then, P2 minus P1 over gamma. So, i-ano lang natin, pagdikitan lang natin. Tapos, take note, yung liquid natin dyan is kerosene. So, we have to multiply yung specific gravity niya na 0.81 times yung unit weight natin ng water. Then, Z2, yan yung magiging datum line natin. So, ibig sabihin, yung Z1 natin is going to be this height. Okay, and that is 0.3. Okay po. Ayan. So, in order to find for the kerosene velocity, substitute natin yung pressure difference na na-solve natin sa letter A. And then, square root natin both sides. No? Cross multiply mo yung 2G, then square root both sides. So, P2 minus P1 as we have solved earlier, that's 90.213 over 0.81 times 9.81 times yung 2G natin. Minus 0.3 muna. Tapos, multiply natin sa twice ng gravity na 9.81. Sir, bakit po 0 yung velocity sa point 2 po? Okay, so as I've mentioned earlier, no, kapag pitot tube yung nasa figure, ang velocity sa point 2 is always 0. Okay po, kasi ang pitot tube natin, yan yung kaniyang purpose, no, para magkaroon ng stagnation sa point 2 and mako-convert yung kinetic energy natin into potential energy. So, magiging 0 yung point velocity sa point 2. So, tingnan mo lang yung figure. Kung nasaan yung dulo ng pitot tube, yun yung point na 0 ang velocity. So, may nagtanong din kanina, bakit daw naging 0 yung elevation. So, kapag kasi, di ba, horizontal, ang ating vectorimeter, so, ibig sabihin yung 0.1 tsaka 0.2, not vectorimeter. Ayan, vectorimeter yung example natin kanina. 0.1 tsaka 0.2, it lies in the same plane. Okay? Now, if they lie in the same plane, and dito si 0.1, and then dito si 0.2, so, ibig sabihin na if you are going to consider yung horizontal plane as a datum line, DL, okay ko siyang DL, 0.1 and 0.2 lies on the datum line. So, ibig sabihin, 0 yung values nila, dalawa. Okay? So, the value of V1 is 14.726 meter per second. So, I think meron mga nakasagot. So, congratulations sa mga nakasagot. Sige, na letter C, what is the flow rate in the pipe if its diameter is 150 millimeters? Flow rate. So may velocity na tayo sa point 1. And then may diameter tayo sa point 1. Tsaka uniform naman yung pipe natin. So, Q equals area times velocity lang po yan. Okay? So, that's Q is equal to area 1 times velocity 1. So, area 1 natin, that's pi over 4 times yung diameter na given, that's 0.15 converted into meters. Square times yung nasolve natin sa velocity 1 na value which is 14.726. So, we can now have a value for Q which is 0.26 cubic meter per second. So, that's the answer for part C. Okay, so you can take a screenshot if you want. So, any question before we proceed to our next topic which is yung Venturi meter? Sir, magmamatter ba if sa point 1 yung datum? If you consider point 1 as your datum, pwede naman, no? 0 yung elevation mo sa point 1, tapos negative yung magiging elevation mo sa point 2. In this particular example, negative 0.3. Okay, kahit saan yung point, pwede yon. Importante lang doon na consistent ka. Kung above sa datum line, yung isang point, edi positive yon. Kapag nasa baba naman, kagaya ng sabi mo, kung point 1 yung gagawin mong datum line, so yung point 2 mo, magiging negative 0.3. Okay? So may nagtanong, lumalabas po ba yan, sir, sa board exam? It might come out. No? Although recently, the last 3 years, hindi siya lumabas. No? But it might come out. Kasi ano din to eh, fluid, may fluid mechanics din. Sir, bakit po 0 yung sa elevation 2 po? Okay, so bakit 0? Kasi yung sa energy grade, sa ano natin, di ba, sa Bernoulli energy equation, kapag consider tayo ng elevation, yung elevation ng point 1 tsaka ng point 2 is always relative to the other. No? So, sa dalawang points na pinili mo, kailangan na yung isa doon magiging 0. No? Which will serve as your datum line. So, in this case, if your datum line is point 2, let's say ito yung datum line mo. Ayan. So, pag sinabing datum line, ang elevation mo dyan is 0 po yan. So, kapag siya yung inassume mo na elevation na 0, ibig sabihin, yung point 1 is, ang elevation niya is kung ano man yung nadagdag sa height niya, di ba? Ang nagdagdag dyan is 0.3. So, magiging 0.3 yung elevation ng point 1. Okay? May tanong pa po ba? Sir, is it always in point 2? If you're referring to the datum line, not necessarily. No, pwede yung datum line mo yung point 1. So, if point 1 mo yung 0 na elevation, so yung point 2 mo, Since nasa baba siya ng zero elevation, of course, magiging negative, tama? Negative 0.3. And your answer will always be the same. Regardless kung anong point yung i-consider mo as datum line. Okay, so are there any other concerns? Sir, sa problem 31, alin po dun yung pitot tube? So, yung pitot tube, yun yung tube na merong patulis. Wait lang. Na-exit yung PowerPoint. Wait lang po suddenly in-exit na-exit yung yung PowerPoint. So ito po yung pitot tube natin. I-zoom ko lang Ayan. So ito yung patulis. Nandito siya. Di lang masyadong clear. Pero may pa ganun yan. May patulis siya dyan. So, yung point 1, yung may velocity na 0. Sa problem 31. Okay? Sige, so ano pa yung mga tanong? Okay, so sa Padlet, merong nagtanong. Sir, kailan po magsi-zero yung velocity? Ano po yung mga conditions po kapag consider po na 0 yung velocity? Okay, so again, as I've mentioned, kung nasaan yung pitot tube natin, yung patulis na tube, yun yung point na yun yung magiging 0. Okay? Tapos, kagaya nito na sa example natin, problem 32, yung point 2, siya yung may patulis. So, siya yung magiging 0 yung velocity. So, ibig sabihin, if maghahanap tayo ng velocity na ng pipe 1. Tapos gagamitan lang natin ng Bernoulli energy equation. Okay, so wala namang tanong. Calling once. Calling twice. Wala na. Sir, may example kayo considering head loss? Yes, mamaya meron tayo. Meron tayo example ng walang head loss. Considering yung head loss. Sige, so proceed tayo. Okay, so let's talk about the Venturi meter. Ayan. So, yung nagtanong ng example na mayroong head loss, so yung concept niya katulad lang din sa bigay example natin sa Venturi meter. Mamaya papakita ko ha paano. Kasi pare-pareho lang yung ano dito principle. So, principle is Bernoulli energy equation. Ang pinagkaiba lang is yung sa pitot tube natin, meron kang point na hahanapin mo yung may point ka na ang velocity ay 0, no? Which is yung point kung nasaan ang pitot tube. Sa Venturi meter naman, walang ganon, no? So, walang point na may 0. So, let's talk about the Venturi meter. So, ito po yung mukha ng Venturi meter natin. Ayan. Ganyan po siya in real life. So, it is a device used for measuring the rate of flow of a fluid through a pipe. So, it's a flow measuring device. Tapos, it consists of a converging part. Yan yung nakikita nating point 1. Tapos, throat naman yung point 2. Yung mas maliit na cross-section area. Tapos, yung gilid, nasa right side ng point 2, yan po yung diverging pipe. Bale, nag-i-expand. Diba? From point 1, medyo malapad yung pipe natin. Pagdating sa point 2, nag-contract siya. Tapos, yung sa diverging pipe, yung sa gilid ng point 2, nasa unahan ng point 2, nag-expand siya ulit. Okay? So, bale, the pipe cross-sectional area is reduced to create a pressure difference which is measured with a manometer to determine the rate of flow. So, ang nangyayari, di ba, sa point 1, you have a certain velocity. Pagdating sa point 2, ang mangyayari, liliit yung velocity, lalaki yung velocity natin sa point 2, di ba? So, since lalaki yung natin, velocity, so, ang mangyayari dyan, yung pressure head dyan, liliit. No? Kasi magbabalance yung velocity tsaka pressure head. So, kapag lumalaki ang velocity head natin, yung pressure head naman mababawasan. So, magkakaroon ng pressure difference sa point 1 tsaka sa point 2. Kukumputin natin yan, no? Using yung concept ng static pressure. Pagkatapos, yung value ng pressure difference, plug in natin sa Bernoulli energy equation. So, masasolve na natin yung velocities ng point 1 at saka ng point 2. So, So it is a differential head type of flow meter that converts pressure energy into kinetic energy. So baliktad siya no sa pitot tube. Ano siya? Um, convert niya yung kinetic to potential. Yung Venturi meter naman is the exactly opposite. Exact opposite. Okay, so considering na walang head loss, so that would be energy at point 1 equals energy at point 2. So derive natin no, paano i-solve yung velocity sa Venturi meter. So ganun pa rin no, in an ideal flow, expand lang natin yung energy equation natin, ganyan. So that would be P1 minus P2 over gamma. Lipat lang natin sa left side yung P2 over gamma. Tapos yung Z2 din, lipat natin sa kaliwa. So that's going to be Z1 minus Z2. And then sa right side naman, isolate natin yung mga velocity heads. Now, if we're going to denote no, yung nasa left side ng equation as H, so the equation will reduce to H is equal to V2 squared minus V1 squared over 2G. So yung sa P2 tube kanina, yung V1 yun yung naging 0, but this time no, hindi yan magiging 0. So gagawin natin, papalitan natin siya ng A2 over A1 times V2. So galing yan sa continuity equation na A1 V1 equals A2 V2. So cross multiply natin si 2G tsaka si H. Ayan. So that is going to become 2GH equals, okay, so yung ano natin, V2 square, so matitira to dito, kinopy lang natin yan. Tapos yung V1, pinalitan lang natin itong A2 over A1 times V2. So, simplifying, and then factor out natin si V2 square. So, that is going to become V2 squared times 1 minus A2 over A1 squared. So, we'll get the value of V2 as square root of 2GH over 1 minus A2 over A1 squared. So, yung ano natin, area 2 tsaka area 1, pwede natin siyang ma-express in terms of pi. So, yung pi over 4, magka-cancel po yan. Ito. So, V2 now is yung formula niya, square root of 2GH. 1 minus D2 raised to the power of 4 over D1 raised to the power of 4. So, again, ang H dyan is yung summation lang ng mga heads natin, no? Both pressure head and the elevation heads. So yeah, let's try to solve this problem. By the way, so ito na yung formula natin, no? In finding for the velocity at point 2. So, pwede kang mag-memorize, but I suggest better talaga if magsosolve tayo ng using Bernoulli energy equation. Kasi hindi ka na maraming isosolve. Pwede din naman to, yung H lang, make sure na palitan mo nitong P1 minus P2 over gamma plus Z1 minus Z2. Okay po. Okay, so let's try to solve problem 33. So, a 150 mm diameter horizontal Venturi meter is installed in a 450 mm diameter water main. The deflection of mercury in the differential manometer connected from the inlet to the throat is 375 mm. So, 3 questions. First, determine the discharge, neglecting head loss. And then, letter B, ito na yung request, no? Compute the discharge if the head loss from the inlet to the throat is 300 mm of water. Ayan, so na-consider na tayo ng head loss. And then, letter C, what is the meter coefficient? Or the coefficient of discharge? Yan yung tanong. Okay, so first is, compute daw the discharge, neglect natin yung head loss. Okay, so still that would be E1 equals E2, energy at point 1 equals energy at point 2. That's walang minus head loss sa equation. Kasi, pinapaniglect ng problem. So, expand lang natin yung energy equation and ganun pa rin. Identify natin yung mga different parameters ng Bernoulli energy equation. So, V1, walang given yan, no? V2, wala din. So, ang gagawin natin ngayon is yung Q natin, no, ipa-plug in natin sa equation ng velocities. Kasi may diameters tayo eh. Sa point 1, that's 450 mm. So, may area tayo. So, yung V natin, pwede palitan natin ng Q over A, no? So, yung equation natin, magiging in terms of Q and the value of the area. Sige, so plugin natin. So, again, remember, V is equal to Q over A. Okay po? So, yan lang yun. So, yung V1, papalitan natin ng Q kasi yun yung hinahanap over yung area sa point 1. So, yung point 1 po, binigyan tayo ng diameter na 450 mm. Kaya yung area dito sa V1 is 5 over 4 times 0.45. I'll convert to meters squared over 2G plus yung pressure head natin, P1 over gamma. Tapos, since horizontal yung Venturi meter natin, so ito yung magiging datum line natin. So, pansin nyo, yung point 1 tsaka point 2, nasa datum line silang dalawa. Kaya 0 ang Z1 tsaka yung Z2. Equals, velocity head sa point 2, ganun ulit, Q over A. So, area ng pipe sa point 2, yung 0.15, yung kanyang diameter. Over 2G plus yung pressure head sa point 2. Ganyan. Okay, so if we are going to transpose itong Q over 5 over 4.15 squared over 2G sa kabila, so magko-combine lang yung dalawa sa kaliwa. Tapos yung P1 over gamma, transpose natin sa kabila. So, then that's going to become P2 minus P1 over 9.81. So, yung unit weight natin na ginamit sa baba ng pressure, that is 9.81 kasi water yung liquid dyan. So, let's say pag sinabing ibang liquid yan, multiply mo lang yung specific gravity ng specific liquid dito sa 9.81. Okay? Now, since tayo dito, meron tayong given a pressure difference. Wala tayong given a pressure difference, pero nandiyan siya sa equation. That's what I'm trying to say. Pero meron tayong manometer. So, concept lang ng static pressure, solve natin muna sa P2 minus P1. So, at this time na, I'll start with point 2. So, point 2 would be still unknown, P2 plus. So, pababa tayo, punta dito. So, that would be a height of Y times yung unit weight ng water, which is 9.81. Tapos, baba tayo ulit. Dito naman ngayon tayo sa column ng fluid na, mercury. So, height niya, 0.375. Multiplied natin sa gamma. So, unit weight ng mercury natin, of course, yung unit weight niya, start tayo specific gravity, so that's 13.6. Times unit weight ng water. So, that's 9.81. And then, lipat tayo dito sa kaliwa. So, pressure dito, same ng value sa pressure dito. Akyat tayo ngayon papuntang 0.1. So, that would be height natin dyan. Start tayo muna dito hanggang 0.4375. So, that would be 0.4375. That's negative kasi paakyat na tayo. 0.375 times unit weight, that is 9.81. Tapos, akyat tayo ulit. That's going to be minus y times 9.81 ulit. Equals P1. Okay, so yung gusto natin malaman, P2 minus P1 po. Okay, so, of course, magka-cancel si y times 9.81 tsaka negative y times 9.81. Isolate natin si P2 minus P1. Yung sagot ay yung simplified answer, transpose natin sa kabila. Sige, so ano yung magiging P2 minus P1? P2 minus P1 is negative 46.352. Tama? So, yung pressure difference na yan, substitute natin doon sa equation natin. So, that's going to become palitan na natin ng negative 46.352 over 9.81. So, one equation, one unknown. QT natin is 0.1712. So, again, we did not consider head loss here. That's why that would be Q underscore T. No? That is 0.1712 cubic meter per second. So that would be theoretical discharge. Okay. May take a screenshot if you want. Okay, so next question. Compute the discharge if the head loss from the inlet to the throat is 300 mm of water. So ito na. Meron ng pinapakonsider na head loss. Okay, so tanong is magbabago ba yung discharge considering yung head loss. So tingnan natin, solve natin, no? So for part B, so ganun pa rin yung equation natin, madagdagan lang ng minus HL. Okay? E1 minus HL equals energy at point 2. Kopyahin mo lang sa baba, expand mo yung energy equation. Yan lang yung basic difference nila. Gawin mo ulit yung computation ng velocity 1, that's Q over the area at the converging pipe. That's pi over 4 times 0.45 square. Tama, over 2G. P1, unknown pa rin yan. Z1 tsaka Z2, pareho silang nasa horizontal plane, so 0. So yung head loss natin, that would be 0.3. No? That is yung given natin, 300 mm. So kapag head loss, minus po yan. And then equals V2 squared over 2G. So that is still Q over velocity. Sorry, Q over area. So that's area natin is pi over 4 times 0.15 square. No, over 2G. Plus yung pressure sa 0.2, wala pa yung sagot. And then Z2 natin, again, same level sila po. So that is 0. So dalawang equation, isang equation, dalawang unknown. We cannot solve that algebraically, so we need to find for the pressure difference muna, no, ng 0.1 tsaka ng 0.2. Okay, so gagawin natin, transpose natin yung mga pressure sa kabila, right side, and as you can see, this is very familiar territory. Tapos, gawin natin ulit yung mga, substitute na lang natin yung pressure difference. Solve naman to kanina. So, anong napansin nyo? Ano yung kaibahan ng may head loss tsaka wala? Yung main difference nila is sa equation lang, no? Nagdagdag tayo ng minus head loss. Okay, sasabab tayo ng pressure. Start ako sa 0.2. So again, from 0.2 to uh, buong height ng point Y, that's Y, times yung gamma natin ng tubig, that would be plus Y times gamma ng water, that's 9.81. Tapos yung head, yung height naman, pababa dito sa, ano to, this is mercury. So that's 0.375 times unit weight ng mercury. So, specific gravity natin 13.6 times yung unit weight ng water na 9.81. Tapos, dito tayo sa kabila. So, from this point, paakyat tayo papuntang point 1. So, that would be a total of y plus 375. Diba? Or pwede na yung isa-isahin. In this case, isa ko siya. So, negative 0.375 ulit. Hanggang dito na point. Hanggang dyan. Tapos, akit ka ulit ng konti. Minus y times yung 9.81. And equals P1. So, what is P2 minus P1 po? So, magka-cancel pa rin si y tsaka ito. So, yan pa rin yung sagot, no? Same lang pressure lang din yan kanina. So, palitan mo lang din dyan ng negative 46.352 will get a value of your Q for part B. So, ano po yung sagot natin sa Q? Paki-type po sa Padlet natin or sa comment section, pwede din. Sir, paano nakuha head loss na 0.3 that is given po? Given po yan. In terms of Q over A para sila mag-equal sa sila ng term sa V2. Hindi naman sa para mag-equal, para lang direkta mong ma-solve yung Q. Yan yung purpose. Bakit tayo nag-Q over area? Sir, isali mo yan sa coming pre-board exam. Secret. Aralin nyo lang lahat. Sir, upload nyo pa today yung PDF? Yes. Sige, pasolve po. Ano po yung Q natin dyan? About the others, ano yung nakuha yung Q? Sir, pwede rin ba na hindi na mag-Q over A? Nasaan na yun? Nawala. Okay, so yung Q natin is 0.1657 cubic meter per second. So, ito na po yung sagot. Okay? Yung kanina, yung sa pitot tube, Yan lang din yung gagawin mo. No? Magdadagdag ka lang ng minus head loss. Tapos yung V1 mo lang, magiging 0, di ba? Ganun sa Pitot tube. Sige, take a screenshot. And then, tanong po sa letter C, what is the meter coefficient? So, yung meter coefficient po, that's referring to the coefficient of discharge, ha? CD. Sige, so solve natin. So, yung CD or yung meter coefficient can be solved, di ba? Using yung ratio po ng Q actual over Q theoretical. So, yun yung mga na-solve natin. Yung letter A, yun po yung theoretical, no? Yung merong head loss. So, that would be 0.1657 over yung Q theoretical natin, na-solve natin kanina. Sorry, yung Q actual, yun yung may head loss, letter B. Tapos yung theoretical, yun yung walang head loss. Or nag-neglect tayo ng head loss sa letter A. Let me clarify that. So, we'll get a new value of C, which is, sige, paki-type na mabilisan sa calculator. Ano po yung magiging coefficient of discharge natin? Okay, so C natin is 0.968. Answer for letter C. So kindly take a screenshot. So meron nung nagtanong, Sir, pwede ba na hindi na mag-Q over A, diretso V na, tapos mag-V times A na lang sa huli? The problem with that is wala tayong values ng velocity. So how can you solve for Q? Ano yung dalawa? And kung titingnan mo, kapag Venturi meter, sa point 1, V1 natin, di talaga natin yan alam. No, walang given na Q eh. Q yung ano eh. Yung sa point 2 din, wala ding velocity. So, dalawa yung magiging unknown mo. So, di mo siya masasolve ng ano, V lang. Naka-V lang. Dapat naka-Q over A talaga siya. Sir, ask ko lang po if i-discuss po ngayon yung open channel po. Salamat. Yung Weir, ano siya, type siya ng open channel, pero yung main discussion ng open channel is going to be next week. Sige, so wala nang tanong, let's proceed to your practice problem. Sige, paki-practice tong susunod na question natin. Sige, so try to solve this one. I'll give you another 10 minutes. Tapos, pag tapos na, post your answer sa comment or dun sa Padlet and then we'll see. Pag 5 students na yung nakita kong nag-submit ng answer, so we'll solve. Sige, so practice. 10 minutes. Okay, so let's solve. Let's see kung tama yung mga sagot ninyo, no? So for part 1, determine the flow of water through the meter. So given na ngayon yung meter coefficient that is 0.68. So anong klaseng discharge to yung tinatanong? Is this actual or theoretical discharge? What do you think? Actual or theoretical? After nitong problem na to, we'll have our break. So pag bibigyan tayo ng meter coefficient, no, ibig sabihin yan, pinapahanap yung actual na values, okay? So in this case, actual discharge yung pinapasolve for letter A. So how do we find for the actual discharge? So of course, we have to use muna yung energy equation na walang head loss. Okay, so bali yung gagawin natin, solve natin yung velocity, sorry, yung theoretical na discharge. Tapos, using yung value ng meter coefficient, masasolve natin yung actual discharge. Okay, kasi wala ding binigay na head loss eh. Sige, so expand lang natin no, yung energy equation. Tapos, ganun ulit, Q over A pa rin. So, yung 0.1 natin, yun yung mas malaki yung diameter. That is 300 mm. So, that's pi over 4 times 0.3 square. Pressure sa 0.1, hindi natin alam yan. Yung Z1 natin, or elevation sa 0.1, that is your datum line. So, 0 natin. Equals V2 square. Plus Z1 natin, that is 0. Equals V2 square. So, V2, that is also unknown. So, Q over A pa rin natin kasi Q yung hinahanap. Iisa lang yung Q natin. So, that's Q over area pi over 4 times 0.15 square. 150 mm kasi yung ano natin, diameter sa 0.2. Over 2G, then pressure 2 plus Z2 natin. So, relative sa 0.1, 0.1 yung datum line natin. Ito yung datum line. Sabihin sabihin, kung ano man yung distance na to, yan yung Z2 natin. So, in that case, that is 750 mm or that is 0.75. Okay? So, ganun ulit, no? Yung mga Q natin nasa kaliwa, tas yung mga pressure sa kanan. Take note lang natin, yung sa kabila, meron pang 0.75, no? Dahil meron na tayong elevation. Okay, tas ganun ulit, no? Solve tayo ng pressure difference. So, concept ng static pressure computation, sasum up tayo ng pressure from 0.1, from 0.2 to 0.1. So, simula tayo dito sa 0.2. So, again, yung pressure sa 0.2, same lang din sa pressure dito sa point na to kasi same level sila. Tapos ngayon, bababa tayo pa ganyan. So, gamma H lang, no? So, that is P2 plus 0.75 times unit weight ng tubig natin, that is 9.81. Tapos, yung Y, tubig pa rin yan. Pwede mong gawin 0.75 plus Y. Pwede ding ibahin mo, Y times 9.81. Pareho lang yan. Tapos, baba tayo ulit, no, ng 0.36. Ayan. Times yung height natin. Ayun yung height natin times gamma. Mercury po yan. So that is specific gravity na 13.6 times unit weight ng water na 9.81. Minus, so minus na tayo kasi umabot na tayo dito sa lowest part, no? Lipat na tayo dito. So akyat tayo ulit papuntang 0.1. So yung total height dyan, that is 0.36 plus y, diba? So pwede mong isa-isahin din. So negative 0.36 muna times 9.81. Tapos minus ka ulit ng y times 9.81. Equate mo siya sa pressure sa 0.1. So magka-cancel dyan yung term na merong y. Kasi parehong ano yan. Parehong value, iba-ibang sign. So P2 minus P1, no, yung magiging sagot dyan is equal to negative 51.856. Yan yung magiging pressure difference natin. Substitute natin ulit doon sa P2 minus P1, doon sa naiwan nating equation dito. Okay po. So, substitute natin. Yun ang compute nating pressure difference. So, negative 51.856. So, solve natin yung Q. Theoretical yan. 0.1722 cubic meter per second, no? Tapos, multiplyin mo siya ng meter coefficient natin na 0.68. Makuha mo na si actual Q. That is 0.1171 cubic meter per second. So this is going to be the answer for part A. Okay, okay po. Kuha naman. So part B, determine the head loss from the inlet to the throat. So yung inlet, yan yung 0.1. Throat, yung 0.2. So bali, pinapahanap ano na yung head loss from 0.1 to 0.2. Ito yan. Okay, so ganun pa rin. Energy equation pa rin. Tas yung mababago lang, ang madadagdag lang is yung head loss. Okay? Okay, so energy at 0.1 equals energy at 0.2. So now we will consider head loss. Yung equation mo, dagdagan mo lang ng minus head loss. Nakuha. Okay, tas expand mo ulit. Ayan. Again, emphasize ko yung head loss. Yung dagdag. Tas ganun ulit. No? Kung ano yung ginawa mo kanina, Q over A pa rin yung velocity at 0.1. That is pi over 4 times 0.3 square. For velocity 1. Velocity 2, Q over A ulit. Ang area mo dyan, pi over 4 times 0.15 square. Yung mga pressure head, solve natin, yung value kanina, yun pa rin. So, nadagdag dyan yung head loss lang. So, essentially, the same. No? Transpose mo na yung Q na nasa right side, lipat mo sa kaliwa, tapos palitan mo na yung value ng Q. Yung ipapalit mo dyan, hindi yung theoretical, but rather, yung actual discharge. Okay, that's 0.1171. Okay? So, substitute na natin to. Ito yung pinalit natin. Ayan. Tapos yung mga pressure, lipat natin sa kanan. Pati yung head loss na unknown. So, yung pressure natin, na-compute na natin yan kanina, negative 51.856. Yung gamma natin, this is water, so wala tayong specific gravity na i-multiply sa 9.81. As is lang siya. Plus yung 0.75, tapos yung head loss plus na siya, no? Kasi negative siya dito. So, transpose mo sa kanan, magiging positive head loss. So, masasolve mo na si head loss, which is 2.438 meters. Answer for part B. Okay? Ayun. Sige. So, questions before we go to the break? Questions sa Padlet? Questions sa Facebook? Wala so far. Sige, so let's have a break. Good morning, sir. Medyo out of topic na question. Ano sa significance sa presence sa mercury, sir? Di ba makuha ang pressure difference if same liquid dra ang naa sa manometer? Okay, so ang pressure difference kapag ang ating manometer is open, pwede mo siya makompute. Pero kapag closed siya, hindi mo siya makocompute. Try natin, no? So, let's say, magko-compute tayo. Let's say, assuming, no, na lahat water yan. Try natin, ha? So, assuming na tubig yan lahat, no? So, let's say, from point 2, gamma H mo is 9.81. Yung height mo dyan, 0.75. Tapos, plus Y times 9.81 ulit. Plus, let's say, yung 360 tubig ulit. 0.36 times 9.81. So, let's say this is P2 plus ano siya. Tapos, minus, kasi aakyat na tayo dito, minus 0.36 plus Y times 1. 9.81 equals P1. So if you have a water, yeah, I think so, no? Pwede siyang ma-solve. Unsay significance? Just to be able to check, no, na ano yung magiging epekto ng ng liquid. Pero if you're going to look at it, no, paano mo lalagay yung mercury sa loob if it's a closed manometer? So, yeah, I have to correct myself. Pwede mo siyang ma-solve actually, no, kahit ano yan, purong water yan. Pero yun nga, no, I think ang purpose bakit yan merong mercury is just to make sure or just to know kung ano yung magiging epekto, no, ng liquid natin na mercury dyan doon sa pressure difference, kung same lang ba, no, kung pure water siya. Pero practically speaking, hindi natin yan ginagawa, di ba? Sa laboratory, if meron kayong lab, sa venturimeter. Hindi tayo naglalagay ng isa pang liquid, no? For a YouTube manometer, yung pressure ng tubig, let's say ganun. So, ano, ah, masasolve mo pa rin siya, no, kahit isang liquid lang siya. So, anong significance? Yun yung naisip ko. Practically speaking, hindi siya ganun ka, ano, significant. Kasi masasolve naman talaga siya kahit water lang siya, pure water. Hmm, that's a good, ano, question. Um, on the other hand, if, ano to, if purong water to, no, wala kang 750, wala kang distinction na magagawa, wala kang 360. 'Di ba? Kasi if that is all pure water, assuming na wala kang mga values diyan, let's say meron ka lang height na y. So, 'di ba yung computation mo diyan, P2 and then minus, so let's say total height diyan is 1,000 mm, so 1 meter, so 9.81 times 1. And then let's say alam mo din tong ano, let's say 1.5. I just want to test, no? 9.8 times 1 point, let's say 1.5 lahat to. Tapos, let's say 0.75. Ito dito, 0.75. Plus 9.81 times 0.75 equals P1. So meron nga siyang ano, meron siyang value ng pressure difference. Sige, so after the break, I'll give you more details about that question. But for now, yun yung masasabi ko na practically speaking, hindi tayo makaka-insert ng mercury kapag close yung manometer. Um, so, I'll think more about it, no, during the break, and then I'll give you more insights. Sige, so let's have a break for 30 minutes. We'll be back by uh, last 30 minutes. So 10:45, and then we'll start a new topic. We'll talk about wears. So another device yan. Sige, so let's have a break for 30 minutes. Hello, good noon. So unfortunately na-block ulit yung video ko kanina. So I'll have to restart this new um, live. So yung previous na first part will be uploaded later. I will upload it again for those na gusto ng replay. And then this will also be uploaded sa website. No? Sige, so we'll have a new lesson. Let's talk about weirs. So what is a weir? So we have here an actual picture of weirs that are installed in open channels, no? So specifically a river. So dalawang klase yung nakikita nyo dyan. Sa left side, that's a rectangular weir. And then on the right side, that is what we call a triangular weir. Because weirs are usually classified according to the shape of the weir plate that is used. Now, ano ba ang purpose ng weir? So, first is it is a measuring device. Okay, so it can be used to uh, evaluate or to determine kung ano yung flow, let's say velocity or yung discharge dyan sa mismong weir. Second, pwede din na gawin siyang regulator, no, ng water flow. What do I mean? So, sa isang river, from upstream, yung tubig mo, syempre, mabilis yan, no? Papunta dito. Ganyan. Now, ang nakaganda dito sa weir is that it, by putting a weir plate, it rises or it raises the elevation of the water. Correct? So, iaangat niya ngayon yung tubig pag ganon. So, inalter mo yung kanyang elevation head. No? So, ang mangyayari to compensate the gain of elevation, mababawasan ngayon yung velocity head natin. No? So, mangyayari, i-convert ng weir natin ang velocity or yung kinetic energy natin into a potential head, no, that is by raising the elevation. So big sabihin nako-convert, no, yung kinetic energy to potential head. Kaya nangyayari diyan sa may weir plate, mas bumabagal yung uh, velocity ng tubig, which means na malilesen natin yung erosion. Okay? Dahil sa mabilis na velocity. So weirs are overflow structures which are built across an open channel for the purpose of measuring or controlling the flow of liquids. So yan po yung primary purpose ng weirs natin. And it has been commonly used to measure the flow of water, but is also now being adapted to measure the flow of other liquids. So ganun siya ka useful, no? Can also be used besides ibang liquid, besides water. So ito yung hitsura ng weir natin. Kung titingnan mo siya sa side, no? So yung nakikita yung kulay brown na parang square na curve yung edges. So yan yung weir natin. So dalawang types kasi yung weir. Meron tayong sharp at saka broad. So ito depende siya, no, sa thickness ng ginamit nating weir plate. So in this case, medyo mataba yung thickness, no, yung thickness ng weir natin. So this is what we call broad crested weir. Ayan, but essentially, yung nangyayari, pag naglagay ka ng weir, aangat yung level ng tubig natin. So, ano ba yung different ng mga parameters na tinitingnan natin when it comes to wears. Okay, so ito yun, no? So, kung titingnan nyo, yung velocity profile ng tubig natin dito sa left side, of course, ano yan, no? As you go down, yung velocity ng tubig natin is mas humihina. And then, as meron tayong tinatawag na channel of approach, which is, ito yung area, or ito yung part ng channel na pinakamalapit sa, ano natin, weir plate. No, weir plate yung tawag na, ito yung weir plate natin. Ayan, tas yung nasa dulo ng weir plate, yun yung crest. Kaya, ito yung tinatawag nating sharp crested. Yung nasa video kanina, yun yung broad. Okay? So, ang nangyayari, yung streamlines natin, no, nagko-contract sila. As you can see, merong drawdown na nangyayari dito sa may channel of approach. Ayan. So, yung drawdown nangyayari siya sa point kung saan nagkakaroon tayo ng velocity of approach. Ito yon. Ang value ng velocity of approach, siya yung average value ng velocity ng tubig dito sa may channel natin. No? Tapos, yung mismong velocity ng flow, yun yung minimeasure natin dito na sa may ano natin. Dito sa may weir. No? So, iba yung velocity approach. Siya yung average value ng velocity ng tubig dito sa may likod ng weir. Yung actual velocity ng flow is yun yung nandito sa may weir talaga. Okay? So, yung weir plate, yung height ng weir plate, tinatawag natin siyang P. Tapos, yung inangat ng tubig from the weir plate to the surface, we denote that as H or tinatawag natin yung head. So, yung nap naman, yan yung sheet ng water, no, that flows out or flows over the crest. So, bale ito yung nap natin. Tapos, crest naman, again, is ito yon, no, yung dulo ng weir plate. Okay, so ano ba yung mga kinds of weir? So, depende sa kind of or sa shape ng weir na gagamitin natin. So, meron tayong rectangular weir. Ibang tawag dyan is suppressed weir. Okay? So, ito yung cross-section ng weir natin, ng rectangular weir. As you can see, yung haba ng weir plate or yung length ng weir plate is pareho siya sa width ng channel. Okay? So, ito yung width ng channel. Ito yon. So, equal siya sa L, di ba? Okay, so yung formula natin dyan to find for the discharge is Q is equal to the wear factor that is denoted as C subscript W. Ang subscript na W dyan stands for wear times the length of the wear times yung head, yung H, capital H, ito yon. Yung measure from the crest to the surface of the water. Okay, times yung length natin, yung head plus yung HV, H sub V. So, anong ibig sabihin yan? Okay, so yan yung head due to the velocity of approach. That is VA squared over 2G. So, ganyan lang, no? CWL times H plus HV 3 halves minus HV 3 halves. Tapos, yung wear factor, yung ano dyan is simply 2/3 squared of 2G. Yan lang yung formula natin. Now, sometimes, yung value ng velocity approach is neglected. No? Kasi medyo maliit lang din yung kanyang value. No? In fact, if you neglect VA, yung sagot niya is comparably similar doon sa value kung merong kinoconsider na velocity of approach. And so, if magiging zero yung velocity of approach, essentially makakancel to. Diba? So what we have is simply CWLH raised to the power of 3 halves. Okay? And then, minsan, sa problems, hindi binibigay yung wear factor. Okay? Itong value ng CW. Minsan hindi yan binibigay. And so, yung formula ng pag-compute ng discharge is simply 1.84 times yung length natin. Okay? So, yung length again is ito. Ayan. Times yung head, which is ito. Okay? So, again, gagamitin mo lang yan, yung Francis formula, if walang given na wear factor sa problem natin. Okay. Now, if meron tayong tinatawag na contraction, no? Contraction is, ibig sabihin yan, yung clear width or clear length ng ating wear is mas pinaliit natin. No? Contraction. So, ito yun. No? Ito yung magiging bagong clear length bale. Ayan. So, nabawasan no, dahil sa contraction na to. Ayan. So, ang mangyayari, yung tubig natin, di ba, kapag merong ganyang contraction, yung behavior ng tubig mo is gaganon siya. Di ba? Tapos dito, straight lang pa ganon yung tubig. Bababa lang siya pa ganyan. Pero dito, sa kabila, is para magkakaroon ng contraction yung tubig natin. No? Dahil sa nilagay natin na parang resistance due to this piece of metal na nilagay na piece of plate na inad natin. So, bale, mababago yung effective length or yung length ng tubig no na length ng tubig kasi kapag suppressed yung length ng tubig equal siya sa length ng wear. Okay, kaya yung Q natin ganyan. Pero kapag contracted rectangular wear, so nagbabago ngayon yung length ng tubig no. Kaya yan yung effective length. So, effective length equals yung clear length ng ano natin contracted wear minus 0.1 times yung n kung ilan yung contraction. So kung isa lang, so 1 lang ilalagay mo sa n. Kung dalawa yung contraction mo, edi 2 times the head. So if you notice, no, yung value ng effective length depende siya sa head ng tubig. So ibig sabihin, no, kung mas maraming contraction, so of course mas malaki or mas maapektuhan yung value ng head natin. Okay? So anyway, so yun lang yung importante dyan. I take note. And then kung dito sa double contraction naman, bale yung tubig mo naman is, di ba, magpo-flow ng paganyan. Bale, parang magko-contract din yung ano natin, yung tubig natin. So, kaya yung mini-measure natin na effective length is kung ano yung bagong length no, na nabawas natin after na minus natin yung 0.1 n times h. So, bale itong term na to, itong 0.1 n times h, it accounts for the changes that happened doon sa length ng tubig, no, or yung width ng tubig after it passes through the contraction. Okay? So, ganun siya. So, L is the measured length of the crest, N is the number of contraction, H is the measured head. Okay? You can take a screenshot if you want. Sige. And then, for a triangular weir, given yung length ng crest niya and then yung head that is measured from the vertex of the triangular weir to the surface, so yung formula po ng Q is equal to this one. That is 4 over 15 C squared of 2GL H raised to 3 halves. Now, if we consider naman yung theta, so yung formula natin magbabago, no? So, that is going to be, so bale, ang nangyari kasi dyan, kapag nag-consider tayo ng theta, so meron tayong triangle dito. Di ba, this is L, total length. So, kapag hinati mo yan, into two triangles, so di ba, this is going to become 2L. And then this one, this is going to become theta over 2, assuming na ang pagkakahati is, if the slope is equal to both sides, so of course, theta over 2. Ayan. So, if you're going to compute H with respect to theta over 2, so bale, yung L mo dito, magbabago ito. Diba? So, sige, try natin. So, yung theta over 2, relationship na niya sa opposite, which is 2L, and then hypotenuse yung H. So, that would be, yung H pala is ito, no? Yung adjacent side ng theta over 2. So, that would be tangent, diba? So, that's tangent theta over 2. Tama? Opposite natin is 2L. Adjacent side natin, ito, this is H. Tama? Kaya, 2L, H tan theta over 2. Ganyan siya. So, yung ano mo dito, yung length mo, itong L na to, papalitan natin ngayon ng this is going to become 2L. Perfect lang to, ha. So, this is going to become 2L equals H tan theta over 2. Tama. Ayan. Hindi pala to 2L, 1 half L to. Kasi kalahati lang ng L. So, 1 half L. So, ganyan siya. So, since 1 half L yan, cross multiply, so that is itong 1 over 2, yung 2 dito, cross multiply mo sa kabila. So, that's going to become L equals 2H tan theta over 2. So, yung L na to, dito sa formula, papalitan lang natin ng 2H tan theta over 2. Okay? So, yung ano dito, itong tan theta over 2, itong L natin, napalitan ng tan theta, ito. Ayan. Tapos yung 2, minultiply natin sa 4 over 15, kaya naging 8 over 15. And then yung H dito, minultiply natin sa H3 halves. No? So, that is H3 halves times H. So, ipa-plus mo lang yung exponent, di ba? So, that is going to become H5 halves. So, dyan galing yung formula natin for triangular V-notch if the slope is equal. Okay? So, again, take note ha, this is 1/2 L. Ito, 1/2 L to. So, dyan siya galing. Sige, you may take a screenshot if you want ng derivation. Tapos, i-erase ko na siya. Okay, so, pinakita ko lang kung saan siya galing. Sige, so I will erase. Okay, yan. So, dyan galing si 8/15. Ito. Tapos, yung wear factor natin is itong 8/15. C squared of 2G. Palitan mo lang siya ng CW. Yan yung letter na gagamitin natin or variable, no, to denote the wear factor. Kaya yan naging Q equals CW tan theta over 2 H 5 halves. Okay? Now, if your triangular wear is 90 degrees, so ito lang yung formula natin. Q equals 1.4 H raised to the power of 5 halves. Another kind of weir is Sipuliti weir. So sa Sipuliti weir, that is a trapezoidal weir which has a slope of 1 horizontal, 4 vertical. Okay. So these are weirs with side slope 1 horizontal to 4 vertical, as I've said earlier. The additional area at the sides adds approximately enough effective width of the stream to offset the side contractions. So yung formula naman po, kapag Sipuliti weir, that's 1.859 LH 3 halves. No? So as long as you have the length, that is the length at the bottom of the plate, and then H the head, so you'll be able to compute the discharge. Sige, can I take a screenshot? Yes, Isa. Ano siya? L over 2. Sige, so let's try to solve some problems. So problem number 1. A rectangular irrigation canal, 3 meters wide, carries water with a discharge of 6 cubic meter per second. A rectangular weir is to be installed across the canal to raise water level 2 meters above the floor, and it explicitly states that you use the Francis formula. So calculate the head over the weir if it is suppressed. Calculate the required height of the weir if it is suppressed, and then calculate the required height of the weir if it is contracted. Okay, so as mentioned, no, the canal is 3 meters wide. So ibig sabihin, ang clear length ng weir natin is also 3 meters. Yung Q naman is 6 cubic meter per second. So binigay dyan na yung H natin ay yung water level is 2 meters above the floor. So lagay natin yung 2 meters. Tapos yung head, as I've said earlier, that is always measured from the weir plate crest to the surface. So yung difference niyan, yung 2 minus H, yan yung tinatawag natin P. No? So again, in this first part, ang tinatanong dito is yung head over the weir, that's H. Okay? So, since sinabi naman sa problem to use the Francis formula, so Francis formula yung gagamitin natin. So, Francis formula is Q is equal to 1.84 times the clear length of the weir times yung head natin raised to the power of 3/2. Sige, so substitute lang natin yung mga given. So, Q that is given as 6 in the problem. Ito. And then, bring down 1.84 times yung length, that's 3 meters, times yung H that is unknown. So, we can now solve for H. So, what is H, ladies and gentlemen? H is equal to 1.057 meters. Yan na yung sagot for letter A. Next, letter B. Calculate the required height of the weir if it is suppressed. So, iba yung head, iba yung height. Yung head is H, yung height ng weir, that is P. Okay po? Sige, so solve natin. Kita naman sa sa drawing, no, na yung P masosolve mo siya as 2 minus H, tama? So, substitute mo lang yung H natin 1.057. So, subtract mo siya from 2, you'll get the value of P as 0.943 meters. Okay, so I would appreciate if you can type the answers in the comments. Okay, next. Part C. Calculate the required height of the weir if it is contracted. So, kapag sinabing contracted lang tapos walang specify kung double or single, so always assume na double, no, yung contraction. Okay? So, kapag meron na tayong contraction, always remember na yung L sa mga formula natin, papalitan natin ng effective length. Okay po? So, that is L minus 0.1 N times H. Okay, so bali magiging ganyan yung figure natin, no? So, gagamitin natin ulit is the Francis formula. So, yung L dyan, papalitan lang natin ng L minus 0.1 N times H. Okay, so solving for H. So, may Q na tayo na na-solve. O, meron tayong Q na given at 6, diba? Okay. So, that is 6 equals yung 1.84 times yung effective length. So, may 3 tayo na value ng L. So, that's going to be 3 minus 0.1 times dalawang contraction times H ulit. H 3/2. So, we'll get a value of H which is, so ano yung sagot dyan for part C? Sir, i-upload po ba ang PowerPoint and live video after the discussion today? Yes. Upload ko kagad. Sige, so what is H? So yung H po dyan, that is equal to 1.1099. Now, since height ng weir yung hinahanap, Diba? So, i-minus mo pa yan from 2. So, 2 minus 1.1099. You'll get the value of P as 0.890 meters. Ito na ngayon yung sagot for letter C. Sige, so take a screenshot first. Hello. Sige, so let's proceed now to our second example for this topic. Okay, so in a channel with a width of 2.55 meters, there is a planned installation of a contracted weir measuring 1.35 meters in length and 1.26 meters in height. The water depth behind the weir is recorded at 2.24 meters. Calculate the flow rate without accounting for the velocity of approach. Letter B, determine the flow rate while considering the velocity of approach. And then letter C, find the velocity of approach in this scenario. Sige, so solve natin siya. Okay, so again, this is a contraction. So, ibig sabihin, sa pag-compute natin ng Q, we have to indicate or to use the value of the effective length. Okay? Taking into account yung pag-contract ng tubig. So, that would be given ba yung length natin? Okay, so that is 1.35. Yan yung length ng weir natin. Minus 0.1 times dalawang contraction times yung head natin, that is 0.98. So, saan galing yung 0.98? So, again, given dito sa problem na yung water depth is 2.24 and then yung height naman ng weir is 1.26. So, minus mo lang 2.24 minus 0.98. 2.24 minus 1.26. That's why meron kang value ng 0.98. Okay, so dyan po galing C, 0.98. So we can now have a value for the effective length. Now, which is that is 1.154 meters. Okay? So yung 1.154, yan yung gagamitin natin ngayon sa formula for finding the flow rate. So, recall natin, no, yung formula, yung tanong walang binigay na C coefficient or weir factor. So, yung gagamitin natin is yung formula ni Francis, 1.84L H to 3 halves. So, since contraction to, yung length natin, pinalitan lang natin ng LE. Okay po? So, substitute natin, that's Q equals 1.84 times yung effective length natin na nakumbit kanina, that's 1.154, and then yung head natin, that is 0.98. Okay po? So, magkakaroon tayo ngayon ng value ng Q. Okay? So, again, for letter A, ang tinatanong dito, flow rate without accounting for the velocity of approach. So, ito po yung formula if we do not account into the velocity of approach. 1.84 LH3 halves. Sige, so ano po yung Q natin? Q is 2.06, diba? Cubic meter per second. So that is for part A. Part B, determine the flow rate while considering the velocity of approach. So kapag kinonsider po yung velocity of approach, so yung conventional natin na approach is itong formula natin na 1.84 LE times quantity H plus VA squared over 2G 3 halves minus VA squared 2G 3 halves. So, substitute lang natin, 1.84 times yung effective length at letter A, that is 1.154, times yung head natin, alam natin that is, ito, no, 0.98, plus yung velocity of approach natin. So, yung velocity of approach, that is simply, paano natin yung isosolve? V squared over 2G. So, ano ba yung velocity sa channel? So, if you notice, wala. Diba? So, pero meron tayong alam na formula for velocity, that is Q over A. Tama? So, gamitin natin yan. Q over yung area is ano to? Kung ano yung area ng channel, no? Yung surface area. Okay, and that would be 2.55 times yung 2.24. Okay, hindi siya surface area, yung cross-sectional area. Okay, double check if that is correct. So, ano kasi to eh? Kung i-drawing mo to, bale, ang ganito siya, no? So, let's say ito yung cross-section ng channel of approach mo. So, 2.55 to, di ba? Yung length ng weir times yung height na 2.24. So, dyan galing C 5.712. Area is equal to 5.712. Okay, kaya may area tayo, no, na 5.712. Okay, so that is for the velocity A. So, pagpatuloy mo lang over 2G. That is 2 times 9.81 minus, no, yung Q ulit. Q over A ulit. Q over 5.712 over 19.62. Ayan, so meron na tayong isang equation, isang unknown, diba? So, yung value ng Q natin dyan is equal to 2.085 cubic meters per second. Yan na ngayon yung flow rate natin if we consider the velocity of approach. And then letter C, find the velocity of approach in this scenario. Okay, so yung formula lang po is Q over area. May Q na po tayo. Flow rate of the velocity of approach, that is 2.085. Ano yung magiging area? So that would be 5.712 ulit, diba? So what is now the value of the velocity? So velocity of approach would be zero point 0.365 meters per second kasi velocity siya. So you may take a screenshot of the solution. So any question about problem 2, you may do it in the Padlet. Sir, bakit po, sir, bakit daw 2H? Saan kayo nagre-reference ng 2H? Yung 0.1 times n times h. So, sa effective length, yung tanong. Ito. So, bakit naging 2H? Ay, bato. Okay, so ito yung formula, di ba, ng effective length. L minus 0.1 times n times h. Yung n po, yan ay yung number of contraction. In this particular problem, double yung contraction natin. No? Kasi yan, ganyan yung natin. Assumption, kapag walang explicit na sinabi, automatic yung assumption natin, double contraction. Okay? So, kaya double, kaya naging 2 yung n. Tapos yung h natin, ganun. So, 0.1 times 2 times h. Sir, tanong ko lang po, yung n sa formula ng LE, nakadepende ba kung double contracted? Yes po. Nakadepende siya kung double contracted or single. Kung double contracted ang minention sa problem, ang n dyan, papalitan nyo siya ng 2. Okay? Or let's say, sinabi sa problem na single contraction siya, so yung n doon, papalitan nyo ng 1. Okay? Tapos, pag walang binanggit na number of contraction, assume nyo na dalawa. Sir, paano po nakuha yung Q sa part B sa problem 2? Q sa part B. Yung Q sa part B, based sa formula. Diyan nakuha yung question. 1.84 effective length times the quantity h plus VA squared over 2G raised to 3 halves minus VA squared over 2G 3 halves. So, dyan siya galing yung Q sa part B. Okay, I'm checking some more questions from Padlet, sir. Ayun na. Sir, kailan po gagamitin ang Weir factor? If may ibibigay na Weir factor or may tanong na involve yung Weir factor, tsaka mo siya gagamitin. Tsaka kung may given din na C coefficient sa problem, which is, papakita ko mamaya. So let's try this problem 3. So the discharge of water in an open channel is 10 liters per second, and the head on the weir is 0.135 meters. So you're asked to determine the vertex angle of the weir if it has a coefficient of 0.6, and then find the weir factor associated with this configuration. And then letter C, you're asked to calculate the percentage error in discharge that would arise if there is a 5 mm error in the measurement of the head. The rate of flow of water through an open channel is known at 10 liters per second. Sige, so meron tayong Q that is 10. You're also given the head, 0.135. So first is the vertex angle daw of the weir if it has a coefficient C. Ayan, so kapag given yung coefficient C, hindi Francis gagamitin mo. Okay? So itong medyo mahaba yung gagamitin mo. That's 8 over 15 C square root of 2G tangent set over 2H 5 halves. So ang tinatanong dyan is yung theta, no? So may Q ka na. Sige, substitute na lang natin. So yung Q natin, that is 10 liters per second. Convert mo lang siya to cubic meter per second. So that's 0.01. Equals 8 over 15 times the C coefficient, that is 0.6. Okay, times square root of 2G, which is constant, diba? Times tangent theta over 2. Theta is what we're looking for. Sige, so manipulate nyo algebraically. So divide both sides by the weir factor. And then arctan nyo times 2, di ba? Para makuha nyo yung theta. Sige. So theta there is tas may h pa tayo, that's 0.135 that is given the problem, raised to 5 halves. Theta is equal to 93 degrees approximately. So that's the answer for letter A. Letter B, determine the weir factor associated with this configuration. So again, yung weir factor, that is simply, no, start ka sa 8 over 15, C square root of 2G. Yan lang po yung weir factor natin. So substitute lang po tayo, 8 over 15 times yung C coefficient na 0.6 times the square root of 2G. Sige, so substitute natin yung C coefficient natin, that is 0.6, and then square root of 2G, that's of course square root of 19.62. So what is now the value of the weir factor? So the weir factor is 1.417. So that's the answer for part B. So take a screenshot kasi maglilipat na ako ng slide. And then part C is yung percentage error. So yung percentage error, no, that is simply, masasolve mo yan if you take the ratio of the error in the instrument over, let's say, the total Q. No, so error of Q over the actual Q. So you'll get the percentage error. Then times mo lang ng 100. Okay, para you'll get a percentage error. Sige, so paano natin siya masosolve, no? So derive muna natin yung formula for triangular weir. So yung Q natin, differentiate natin. So dQ equals CW, and then power rule ng differential. that's 5 halves times h, and then 5 halves minus 2, that is h 3 halves dh. And then i-ratio mo lang yung dalawa, dq over q. So yung terms ng dq, lagay mo dyan. Okay, that's it. Then yung dq, and then q is cwh 5 halves. So ano yung maano natin dyan, madi-derive? So dq over q, yan yung relative error natin. So yung CW obviously magka-cancel to. Tapos 5 halves is 2.5, diba? And then yung H natin dito, ito makaka-cancel to. And then bababa lang, no, dito sa mamaminusan. So yung H3 halves minus itong nasa baba, factor out mo din yung H3 halves. So H2 over 2 na lang, or that's 5. So essentially ito na lang yung formula natin, no? 2.5 dH over H. Okay? So yan lang siya. So try natin gamitin sa formula. So that is dq over q, 2.5, tapos dH is the change in error. So sabi dito sa problem, merong 7 mm na error. So lagay mo yung 0.0007 over yung total head. Sige, so dH natin, that's 0.007, that's a percent error, over the total head, that is 0.135 as given. Ito yan, 0.135. So what is now the relative, multiply mo siya ng 100 para maging percent error na siya. No? So yung dq over q, that's what we call the relative error. Pag multiplyin mo siya ng 100, magiging percentage error na siya. So that's 12.96%. That's the error for letter C. Sige, may take a screenshot. Sige, so let's move on to problem number 4. So let's have a trapezoidal weir. So the discharge over a trapezoidal weir is 1.315 cubic meter per second. Then binigyan tayo ng crest length, which is 2 meters, and the sides are inclined at 75 degrees, 57 minutes, 4.9 seconds. Find the head on the weir in meters. So wala tayong ibang formula for weirs, diba? It's only Sipuliti. So if ever may binigay trapezoidal weir, so check nyo yung angles na binigay. So it states that merong angle of inclination na 75 degrees, 57 minutes, 49 seconds. So check natin if kapareho ba siya doon sa 1:4 na slope ng Sipuliti. So compare lang natin, no? Tangent ng theta, that is 4/1, opposite. Ito yung angle natin, no? Ito. So opposite niyan is 4, adjacent is 1, diba? Okay. Now, if we're also going to compute tangent ng given angle that is with respect to the horizontal, that's 75, 57, 49, yung value po niyan is pareho lang. Ibig sabihin po na Sipuliti na formula yung gagamitin natin dito. No? So hence the given inclination is that of a Sipuliti weir. So yung formula ng Sipuliti, that's Q is equal to 1.859 LH raised to the power of 3 halves. Substitute lang natin, no? Given naman yung length, tsaka yung Q given din, no? That's 1.315 ito. Sulat lang natin dyan sa Q. And then equals 1.859 times the length of the crest, that is 2 meters. And tapos yung h naman, that is the question. What's the head of the weir? So what is h? H is equal to 0.5 meters. Answer for problem 4. No, sorry. Na-mute ko pala. Saan ba ako nawala? Ah, part A. Saan ako nawala, sa part A or sa part B? Part A. Sige, ulitin natin. Okay, so again, as mentioned, pinapagamit yung 90-degree na triangular weir. So for a 90-degree triangular weir, yung formula po natin is isa lang, na 1.4 h5 halves. Huwag ka na mag-isip. Yan na yung gamitin mo. Okay, tas substitute mo na lang yung h na 0.3 Ayan, raised to 5 halves. So you'll get a value of Q which is 0.069. Now, remember, the question is asking for in terms of liters per second. Diba? So, convert mo. No? Sa isang cubic meter per second, meron kang 1,000 liters. So, times 1,000 mo yan. Diba? So, Q is equal to, that's going to become 69 liters per second for part A. Okay? So, I hope that's clear. So, ano lang yan? Direct substitution lang ng head. Letter B, if it's a trapezoidal weir with sides inclined 14.04 degree with the vertical. Ayan, so if i-check mo sa Sipuliti, again, yung Sipuliti, that is 1 horizontal, 4 vertical. No? Bali ganito. One horizontal, 4 vertical. So, ang question sa letter B, ang angle daw with respect to the verticals, ito yung vertical, ito yung vertical natin. So, ang tinatanong is, ano daw tong angle na to? So, di ba that is arctan opposite 1 over 4. Arctan 1 over 4, that is equal to 14.036 or 14.04. Therefore, ang given na trapezoidal weir with a given angle is that of Sipuliti. Now, since Sipuliti siya, gamitin mo lang yung formula. Formula natin is simple lang, 1.859 LH 3 halves. Yung length ba given, binigyan ka ng length, that is 2 meters. Ayan o. So, yung 2 meters, substitute mo yan sa L. Yung H natin, given, that is 0.3. So, lagay din natin yan sa H. So, diretso, makukumpute na natin yung Q. So, Q is equal to 1.859. So, yung length na 2, H na 0.3. You can now solve for Q. That is 0.611 cubic meter per second. Times 1,000 to get a value in terms of liters per second. 611 liters per second. Answer for part A and part B. Sige, you may take a screenshot if you want. Okay. Part C, if a contracted rectangular sharp crested weir 2 meters long is used. So, hindi yan link, that's long. So, ibig sabihin yung clear length ng ano natin, ng contracted weir is 2 meters. Okay? So, ito yung formula ng contracted weir. So, that's 1 point, ito yung formula ng Q. Francis yung ginamit natin dyan kasi walang binigay na C. So, that's 1.84 LEH raised to 3 halves. So, yung LE natin, as you know, that is 2. That is the crest length. Minus, bawasan mo siya ng 0.1 times N natin. Dalawa yung contraction. Times 0.3. So again, pag walang binanggit na doubly ba siya or singly, so automatic assumption natin na doubly contracted siya. Okay? So yung Q natin there, and then may H na tayo, that's 0.33 halves. Answer for Q is 0.176. Tapos convert mo siya into liters per second, multiply it with 1,000, we'll get a Q of 176 liters per second. This is the answer for letter C. Okay, now let's have an example of an unsteady water flow. No? So the flow of water from a reservoir passes through a 12-meter long spillway and is 4 meters wide. If the water supply in the spillway is cut off, how long will it take for the water to be drawn from a head of zero point 0.4 to zero point 0.2 meters? So weir factor is 1.84. So ito yung mukha ng ano natin. So yung H, capital H, ito. Yan yung original head. No? We call that H1. Tapos ito naman, ito yung H2, yung final head. No? So after maputol yung supply ng tubig, so obviously, bababa yung level ng tubig natin. So ang tanong is, how much time yung kailangan dyan, no? Para ma-draw or bumaba ng at least 0.2 meters. Okay? If naalala nyo dati sa orifice, no, meron tayong formula na T is equal to integral H2 to H1, that's ASDH over Q, or AS there is the surface area, and then times yung DH over Q. So yung bago lang dito is yung Q, no? Papalitan mo lang siya ng CWL H3 halves. Okay? So yung formula natin is going to become 2AS over CWL times quantity 1 minus square root of H2 minus 1 over square root of H1. So, substitute mo lang yung dalawang area natin. Yung area natin, rectangular yan, no? So 12 times 4. So that's it. Over CW, that's 1.84 given siya. That's ito. And then yung length natin, that is 12 meters long. Sorry, yung length is not, okay, yung length is always pareho siya sa width ng channel. Okay, so always remember that. Baka kasi yung length na 12 meters yung ilagay nyo dito sa L, so hindi po mali po yan. Yung L dyan is the length of the weir, which is corresponding to the width of the channel as well. Okay, times, okay, yung 1 over square root. So yung H2 natin, yun yung final na depth. So that is 0.2. And then yung H1 natin is yung initial depth, that is 0.4. Sir, parang nag-feedback yung audio nyo po. Okay, maybe it's the electric fan. Okay, so the value of T is equal to 8.54 seconds. So, yan na yung sagot natin for this particular problem. Okay? And I think this is the end. Yeah, this is the end. Sige, so questions before we go? Questions po? So yung recording kanina, I will upload it again later for your reference, yung nawalang video. So you still have 3 minutes for questions. Yes, I will upload the video and the PowerPoint. Q&A po tayo. Any other question? Sige, so kung wala ng question, thank you so much for today. And good luck sa upcoming pre-board niyo. I think it's going to be on Saturday. Sige, so thank you everyone and have a great day ahead. So see you later this evening for the consultation. So we will answer yung mga tanong from previous topics. I think sa week 10. And then kindly prepare your questions as well if you have questions. Okay, so God bless everybody and have a great day. Thank you so much for listening.